Good morning. In the last video, we discussed the area moment of inertia of an angle section. I have given the link of that video in the description. Those who haven't seen that video, please go through that. In this video, we are going to find the area moment of inertia of a Z section. Now let us go to the problem. Calculate the moment of inertia of a Z section shown in figure by centroidal axis. Also find the polar moment of inertia. So this is the given Z section and the dimensions are given here. Width B equal to 5 centimeter. So this is 5 centimeter and here it is 5 centimeter. Height H equal to 10 centimeter. So this is height which is equal to 10 centimeter. Then thickness equal to 2 centimeter. So the thickness of this Z section is equal to 2 centimeter. This is centroid and this is centroidal x axis. This is centroidal y axis. We have to find the moment of inertia with respect to these two axes. Then we have to find the polar moment of inertia. Now let us go to solve the problem now. The first step is divide the composite section. We all know that we can find the area moment of inertia of a regular sections directly using the formula, but here it is a composite section. So we cannot find this area moment of inertia directly. We have to divide it into regular shapes like circle, square or rectangle, etc., etc. I have put a separate video for area moment of inertia of various sections. I have given the link of that video also in the description. Those who haven't seen that video, please go through that. Now I am going to divide this Z section into three parts. So this is the first one, first rectangle 1, and this is my second rectangle 2, and this is the third rectangle. So this is what here I have given, first rectangle plus second rectangle plus third rectangle. When you add this one, you will get the Z section. In the second step, take the first rectangle and draw a separate diagram for it, and let us go to the composite section again to see the dimension. Now this is equal to 5 centimeter. Here it is given as 5 centimeter and thickness equal to 2 centimeter. Here it is given. So take this one is 5 centimeter. Here it is 2 centimeter, and make sure that these axes are positioned correctly. Okay, and with the help of this one, with the help of this composite section, then you have to find the values for 5 variables. The first 3 variables are common to the centroid, and the second 2 variable is specific to the area moment of inertia. Now let us go to the first one. X1 equal to, it is the distance between y axis and G1. So this is the x1. First you need to know this distance. Okay, if you refer here, this is the distance. So this is the distance. Okay, and you know that the total distance from this end to this end is b, which is equal to 5 centimeter, but you have to subtract this thickness 2 centimeter. So this distance is now 3 centimeter. So you have to add it. So 3 plus again it is 5 by 2, which is equal to 5.5 centimeter. Then y1, distance between x axis and G1, which is equal to 1 centimeter. Then area 5 into 2, it is 10 centimeter. Now you have to find Ig1x, where I refers to area moment of inertia. G1 is this one. Now this x is nothing but the axis passing through this G1. So this is the x axis. So you have to find the area moment of inertia with respect to this one. So here it is b d cube by 12. Substitute the values, you get the answer as 3.33 centimeter to the power 4. Then the final variable is Ig1y, which is nothing but the axis passing through this G1. So this axis. So you have to find the moment of inertia with respect to this axis also. Okay, the formula is db cube divided by 12. Substitute the values, you will get the answer as 20.33 centimeter to the power 4. Then for the second rectangle, you have to find the values for 5 variables. First one is x2 equal to 3. Here the 3 is added because this object is located from y axis by 3 centimeter. 3 plus here it is 2 by 2 which is equal to 4 centimeter. Then y2, okay, you see here this rectangle is located from x axis by 2 centimeter. So you have to add these 2 plus 6 by 2. 6 is nothing but this height, and you will get the answer as 5 centimeter. Now A2 equal to area of this rectangle, which is 2 into 6, 12 centimeter square. Again IG2x, which is nothing but the axis passing through this G2. Okay, so you have to find the moment of inertia with respect to this one. It is nothing but IG2x. Okay, formula is BDQ by 12, 36 centimeter to the power 4. Similarly, IG2y, which is nothing but the axis passing through this one. This is IG2y. You have to find the area amount of inertia with respect to this one also. Formula is dB cube divided by 12. Substitute the values, you will get the answer as 4 centimeter to the power 4. Similarly, you have to find for the rectangular 3 also. Okay, x3 equal to 5 by 2, total distance by 2, 2.5 centimeter. Y3, you see here this rectangle is located away from y axis by, here it is 8 centimeter. So you have to add that one, 8 plus here this height is 2, so 2 by 2 which is equal to 9 centimeter. A3, area of this one which is 10 centimeter square. Then IG3x, which is nothing but this one. This is that axis. So you have to find the moment of inertia with respect to this axis also. Similarly, this is y axis. So you have to find the moment of inertia with respect to this axis also. Okay, so this is what here it is found. Now the third step is finding the centroid. Use summation formula. Now x bar equal to x1 a1 x plus x2 a2 plus x3 a3 divided by a1 plus a2 plus a3. Substitute all the values we found earlier and you will get the answer as 4 centimeter. Similarly, for y bar, use again the same rule, y1 a1 plus y2 a2 plus y3 a3 divided by a1 plus a2 plus a3. Substitute all the values, you will get the answer as 5 centimeter. The next step is you have to find the moment of inertia with respect to centroidal x axis, centroidal y axis. There are 3 sections we have divided, 3, 2 and 1. So first you have to find the moment of inertia for each section, then we have to add. So this is what here it is done. IGX, moment of inertia with respect to centroidal axis, equal to moment of inertia for the first section plus moment of inertia for the second section, moment of inertia for the third section. You have to find separately, then you have to add them to get the final moment of inertia about centroidal x axis. Now this is the centroid, this is centroidal axis about which we are going to find the moment of inertia. Now we know the moment of inertia about this g1 and x axis. We know the moment of inertia about this axis, okay, ig1x. Now we have to find moment of inertia about this axis. You see here these two axes are parallel to each other, separated by this distance d. Now I can use the parallel axis theorem. So here it is Igx equal to Ig1x, okay, moment of inertia about this axis, plus area of this rectangle 1 a1, then this distance square, distance between these two axes, centroidal axis and g1 x axis. So here it is d1 the whole square. Now you have to, now you know the answer for this one, ig1 x, but similarly a1 also. You have to find the answer for this d1. Okay, now let us go to the diagram again. You see here y1 equal to distance between these two is y1, and distance between this x axis and the centroidal axis is y bar. Okay, so if I subtract y bar y1 from y bar, then I can get the answer for this one. So d1 can be written as y bar minus y1. Okay, so, or otherwise This can be written in another way also, y1 minus y bar, because I am going to take the I am going to square this value. Okay, so minus plus doesn't matter, everything will be squared into a positive number. Now this formula is substituted here. Okay, so ig1x plus a1 y bar minus y1 the whole square. Okay, similarly in the same way I am going to find the mode of inertia for this I2x, the second rectangle, ig2x plus a2 y bar minus y2 the whole square, plus this is the mode of inertia for the third rectangle, ig3x plus a3 y bar minus y3 the whole square. The concept, all the formulas are having the basic concept as this one only. Okay, so substitute and substitute all the values, finally you will get the answer as igx equal to 362.66 centimeter to the power 4. Similarly for igy, mode of inertia with respect to centroidal y axis, I1y, this is with respect to this is for the first rectangle plus second rectangle plus third rectangle. Okay, when you add these three you will get the mode of inertia for the central y axis. Now the same formula, okay, the same concept is used here, but in the place of this one ig1y is used. Okay, similarly here x bar minus x1 is used. Okay, so this is the difference. Similarly this is for the second rectangle and this is for the third rectangle. After completing this equation, substitute all the values, finally you will get the answer as igy equal to 89.66 centimeter to the power 4. The second one is polar moment of inertia. You have to find polar moment of inertia is nothing but it is the moment of inertia with respect to z axis. So I am going to use perpendicular axis theorem. Okay, which is nothing but igz equal to igx plus igy. Substitute the values from this one and this one into this equation, we will get the final answer as 452.32 centimeter to the power 4. This is how the solution is arrived for moment of inertia about centroidal axis and the polar moment of inertia. Please go through this video one more time to get better understanding. Okay, thank you. We will meet in the next video where we are going to solve the third problem in area moment of inertia. Thank you.